In this demonstration, I would like to show you how to do mixed protocol. That means when you have Dynamixo that is on protocol 1 like AX12, and then Dynamixo like on protocol 2, which is like the XL320 here. And first, let's talk about what system I have here. So I have AX12 CarBot 1, 2, 3, 4 for the servo. LiPo 12-volt batteries, and because I'm using 12-volt battery, I cannot plug that power directly into the CM904B here, so I have to go through a 45EXP expansion board. So you notice it's 1, 2, 3, 4, 5, 1, 2, 3, 4 AX12 dynamics, so I hook up to the 45EXP. So that corresponds to serial 3 as far as programming of the RoboDisc IDE is concerned. I have a BT210 hook up to the Open904B here. I also have XL320 and hook up as a position control 2 on it. So it goes on to the OpenCM 904B bus directly itself. So this is serial 1. And the VT is communicating through serial 2 here. You also notice that I have 2 LiPo battery, the small one for the OpenCM board, and I hook up to it. And right now I have it on. I also have the Bluetooth power switch on too. Just this is to make sure that my XL320 is powered by the proper voltage, because I'm having a mixture of voltage in my situation here. So the AX12 down here are driven by the LiPo down here, which is 11, 12 volt usually. And so you see this one, this is the situation. Later, I will show that although this program can be run without with the power from the LiPo going up to the OpenCM B, now 4B, but watch out, there's something happened to the AX12 servo, but we'll get to that. We'll do the good demo first, and then we'll show probably what we get into. Also, you notice I still have the USB plug in so that I can see the output from the USB serial printer that this program runs. So now we got setup design there. Let's go and talk about a little bit about what the code is about. So I'm using the RC controller, so I had to make sure I have the include RC100.h file. I'm defining my my RC100 object, and I call controller. So reminder again, just serial 1 if you have it right on the OpenCM 904 board. Do you plan to use any kind of LN101, BT210, BT110A, ZigBee, 110A, that sort of thing? You make sure you use serial 2, plus serial 2. And then if you have, in my case, 45EXP with servo on it, that's serial 3. So I'm using the AX12 servo and the IDE 1, 2, 3, 4. The XL320 itself is its ID is number 6. I also define some global variables. Goal speed 32, goal position 30. These, of course, are the addresses of the goal speed and the address of the goal position from the control table. So now this is an important one. So essentially, when I command the servo, I actually have 2 Dynamixo objects, shall we say. The first one, the DXL I use that to control all the AX12. So I call that Dynamixo declared as an object called DXL, and it's on serial 3. And so in my future plan, I plan to have this one like a mobile manipulator. So the AX12 here will be part of a little arm to manipulate things, but right now it's only have 1 servo, but just to illustrate the concept here. So I call it DXL arm, and it's on serial 1 because it stay on the OpenCM 904B board itself. So that's for this guy. Okay, I declare some variables, receive data, car data, and ARM data. And I will show you why in a minute. So as far as the setup goes, initialize DXL. That means that's the one on serial 1. Initialize the bus at 1 megabits a second. And then because I'm using AX12 down below here, that's a DXL packet type 1. So you have to make sure you set the packet type. And then I send command to make it join mode for ID 1 and 2. 1 and 2 here is in join mode in ID. And then I tell it to set up the goal speed of 512, which is halfway there. Sometimes I found out these kind of command join mode or will mode sometimes doesn't work. So watch out for that. I had to go in and set these things before I download this code for some reason. Many times it does that. So watch out. Sometimes you may have to go a regular controller, go to manager tool and set up all your servo to the mode that you want. This one, I don't trust through software. I'm having a problem with it. It's not reliable. But you can see that 1 and 2, I want it to be in join mode. And 3 and 4 is in will mode. So 2 will in the back will mode. So that's a dynamic cell packet type 1. Because they are on, so remember, it's DXL serial 3 for the AX12, and they are packet type 1. Okay. Once you're done that, initialize my DXL on. Because that is controlling only one XL320 ID number 6 right here. Okay, so I'm going down. Begin at mode 3 again, 1 megabit per second for the bus. Set packet type 2 to be sure of that. And then I tell number 6 to go to join mode. And then I set up its goal speed to be 800. So this guy a little bit faster than the other AX12 servo. Pin mode, you don't need it. And then initialize my RC100. Make sure I can communicate through the Bluetooth. And then of course we have our big loop. So I clear out my receive data. And if the controller variable, that means somebody sending over data something. And then we can do that. So I pick up the data, save it in there, print out on serial USB port. Let's see, so I have it here, so it will show up here. Okay, so now I'm reading the received data, and the way I set it up is you can combine up, down, to control up, down, left, right to control the CarBot. So whatever received data is, I AND it with 15. Basically, the first 4 bits are set to 1 to remove all the other data that I don't want. Then the ARM data, because it comes from the button numbers, the numbers button, 1, 2, 3, 4, 5, 6. So I AND it with 1008 to save that data in the separate parameter here. And then we have a bunch of if-else if structure. If the car data, find out if you push a U button, and then you set your packet type 1. You send the goal position, ID number 1. So make 1 here, go to position 1, delay a second or 1000 millisecond, and then tell it to go to 1023 and delay again. So if I push the U button, you see 1 go to 1 and then go to 1023. That's all it does. Anytime that it detects there is a U button. If I push the D button, and then similar thing, it go between 200 and 800 on servo number 2, which is on this side. And if I push the left button, it set up the goal speed for 3 and 4. Because if you have to remember, it's 3 and 4 are in will mode. So this is kind of a weird robot. Back here, the will mode, but up here, the position control. This is just an example to illustrate some concept only. So this is left, and then it basically turn left, right, turn right. Else, well, just turn 3 and 4 off, so don't move anywhere. So that's just to that's if else if structure. Else structure is to take care of the car data information. And then of course I have another set for the ARM data information. So you found out that I pushed the button 1. This is sending command to ID number 6, which is packet type 2. So I have to declare that to be proper. So if I push 1, it moved between 1 and 1023. Server number 6, which is the XL320 here. You found out I pushed 2, it moved between 300 and 700. That's the basic code. So let's see how it's working. And let's see this cooperating. It's here. I also have hooked up the virtual controller already in, and everything hooked up, and see if it's working for us here. Oh, also very important right now is I have the CM904B powered by itself, like I mentioned before. And then the LiPo down here, it operates the X12 servo down there to full power. Let's see if everything's working. So if I push up button, okay. So you see, I tried to click on it, but it actually sent out 4 times. Let me gonna hit the keyboard, the up arrow button only once, real quick here. So at least I managed to have 3 times this time, but it's setting everything. So you see there's a deal with communication. We have to do some filtering, some fancy algorithm here to make sure that you don't want to execute more than you want. So if I push D, there's servo 2. Okay, there's 4 times too. Touch the real light here and say, okay, I just managed to do 2 there. So now I'm going to push either 1 or 2 to take care of the XL320. Remember, this is a different packet type and different serial port and all that stuff too. So let me see. Okay, I put the button number 1 only 1, but it's gonna do it 4 times. Yeah. Put it real light. 2 times. 3 times. Here we go. Three times. So then you need to do lots of little debouncing code. Okay, let me leave it down. I'm going to try to do is push 1 and up at the same time keyboard. Right, you can see that they're going to go. They should activate both this one and this one. Let's see. Okay, so they're not 17 twice. So let me try it again. Okay. Oh, remember I promised you to show you what's going on the power here. So remember in the previous demonstration previously, I had the power on the now 4B on also. Okay, and the code actually can be powered from the LiPo battery down here. So I'm just going to turn on only the power on the 45 EXP. Okay. And let's bring back in the virtual controller. Here we go. Also, let's bring in the serial monitor. Bring it in here. Okay, the RC100, everything is in here. Now, so remember, I'm only powered through the CM905, the 485 XP, I mean. So the power on the OpenCM 904B is not on itself. That means not through these the smaller LiPo battery. Okay, so the program is running now. Everything's solid. And let's see if it's working. Okay. So it does the stuff as normal. And if you remember, this one is activated through the keyboard 1 and 2, okay? So I'm going to push 1 soon here. Okay, 1 and 2, it is sending. And then send 32, but nothing much happening. And then the red LED on the XL 320 touch lighting up. Okay, so when you have the mixture of power issue, watch out. It kind of get complicated if you build a more complicated bot. So look like the XL 320, because it's run on different voltage, the battery powered through its own LiPo batteries. Okay, and so watch out. Even though this driving around, but you're gonna have this kind of unstable situation. So first, let me turn everything off. Okay, and then I'm actually using LiPo battery here. Turn that one on, so you see it's live with this one. Turn that one on. Put my COM port in. I'll have to refresh these guys. So, monitor back in. Bring these guys in. And let's see, everything's still behaving as they should. There we go. But you got stuck there a long time. Let me do real quick. That's a number 2. Now, so remember, so everything powered on its own now. It has essentially 7 volts into it only. 1. Push 2. It does it properly, you see? No red light flashing or anything. Okay, so when you have mixture of power and dynamic, so watch out. You have to be more careful about how much voltage you supply to who and where, and serial this, serial that. Later.